Hello, my name is Kainton, and today we are going to continue with the second lecture in the series of Introduction to Hashing. And there is a course on the data structure and algorithm for computer science students, and also if you would like to learn more about hashing. So I also like to remind you to subscribe if you've not done so that you get notified when I make new lessons. Alright, so in this series we are discussing all of this. So this covers everything we are going to learn in the first part of this 4-part series. Today we are going to cover problem of direct addressing, and also we are going to look at hash functions, concept of collision, and resolving collision by chaining. I'll try to be as simple and clear as possible. If you like, you can take a pen and a paper and take some notes. So what is a problem of direct addressing? One of the problems of direct addressing is that if the universe is too large, then storing table of size U will be impractical. So if you have a set of items that range from 1 to M, okay, so where M is very large. M is very large. It's let's say some value. So what it means is that we need to allocate space to store this M from 0 to, so this is just an arbitrary value I use, but what if it's really large? That means we will allocate so much space, and that will be impractical because we can't have computers allocate indefinite amount of space. So that is one of the downside of arrays or direct addressing. The next one is space may be wasted if the set of keys is too small relative to U. So we take the same example. Let me get my pen. So if we have a series of values, let's say we want to store values 3, 4, 5, 6. We want to store 4 items, right? And then we have is the set of keys that actually contain values. So we have 0, we have 1, 2, 3, 4, 5, 6. So in this case, we see that data is stored in 3, is stored here, is stored here, and is stored here. So in this case, we have the set of K the keys is small relative to the universe, or relative to the total of values that can be stored in this table. So we have wasted space. So this will be also more difficult if we have values stored here in this place. So in this case, we have a series of positions that are wasted, and then we also have a problem when we have to search or insert items into this table. So these are some of the downside of direct addressing. There are 2 of them. Storing size of creating a table T that has a very large size is not practical, and also space may be wasted if the set of keys is small relative to U. Alright, so let's now look at hash function. For us to understand hash function, let's just go back a bit to what we already know. So already you know that if you have a table and you want to store items in this table, so you have, let's say, item like the first item Ben, you store it in key 0 or position 0. So you have Ben. So let's say the next one is or B, you store it in position 1. Okay, so it goes here. So it's pretty easy to manage. So, but let's now look at a situation whereby instead of storing it in these positions, you actually use a function to come out with the position to store this. So what we'll have if is a situation whereby, let's take another example. So let's say we have a function h that takes in Ben and then produces a value. So we pass Ben into this function, it gives us a value, right? So this value is where we are going to store the data bank. Let's take a typical example. We want to store data of let's say we want to store this set of data 2, 3, 4. Let's say we have h of x is equals x. Let's take for example. So now we want to store 2, right? So h of 2 equals 2. So meaning that we are going to store this value here, right? We want to store 3. H of 3 equals 3. So it's not also a problem, right? And then we have h of 4 equals 4. We store it in here. So this is basically how the simplest hash function I can think of. Alright, let's now take a look at another kind of hash function, because we are still talking about hash function. So let's assume that you have a hash table and you want to store items in it. Before we use h of x equals x as the hash function, let's outline this. Alright, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So let's take a hash function h of x equals x mod m, where m is equal to 9, which is the size of this table, right? Good. So let's take, for example, want to store the items, these items like 5, 3, 12. Okay, so let's say we want to store this item. So we say h of 5 is equal to 5 mod 9, right? What does it give us? It gives us 5. So we store it here, right? So let's take the next one, h of 5. H of what? Of 3 is equal to 5 mod 9, which gives us what? 5 mod 9 gives us 4. No, 3. 3 this time. 3 mod 9 gives us 0. So we store it here. H of 12 is equal to 12 mod 9, which gives us what? It gives us 9. So we store 12 mod 9 is going to give us 4. So we store 12 mod 9 is going to give us 3. So we store it here. Let's assume we want to store more values like 13. So let's try h of 13 is equal to 13 mod 9, which is going to give us 4, right? Good. So we store it here. So let's take another one. 15. H of 15 equal to 15 mod 9, which will give us 6. So it's not a problem. Okay, let's now take another one. Let's say 2. So we have h of 2 is equal to 2 mod 9, which will actually give us let's say 0, which will give us 1. So it's not a problem. So we store it here. So finally, let's now take 4. H of 4 equal to 4 mod 9, which will give us 5. So in this case, we have a problem because it also comes to this place. So how do we put the same thing in the same place? So that means a collision have occurred. So in this case, we can solve this problem by using chaining. So how does chaining work? Chaining simply says that store the items in a linked list if they have the same hash value. So what it means is that if you have a hash table and 2 items, let's say we have 0, 1, 2, 3. So h of x gives us what? Let's say it gives us 3, and h of y gives us 3. So h of x and y gives us 2 to the same hash value. So it means that we need to use a linked list in this place. So store the first one 3, and store the first item here, and store the next item here. Maybe we discuss more about linked lists in the next class, but I'd like to thank you for viewing. If this has been informative, subscribe and also like this video.